In this video, I'd like to solve some absolute value equations with you. Before we get to the equations, let me remind you how we take the absolute value of a number. For example, suppose we were going to take the absolute value of -5. The result is the distance that -5 is from 0. So we say that the absolute value of -5 is 5, because if we drew our number line, -5 is here. This distance is 5 units. If we take the absolute value of 3, for example, we would look at this number over here and notice its distance from 0 is 3 units. So the absolute value of 3 is 3. Recall that the result of taking an absolute value will always be non-negative. That means it will be either positive or 0, because we could take the absolute value of 0 and we would get a result of 0. So that brings me to solving some equations. Let's look at a basic equation like this. The absolute value of x equals 10. So we're being asked to find all of the numbers whose distance from 0 is 10 units. And if we looked on our number line, we find two numbers whose distance from 0 is equal to 10. Those numbers are 10 and -10. So in fact, both of these numbers are solutions to the equation written above. So let's write those solutions. X equals 10 or x equals -10. If we were going to answer it formally, we would answer in set notation, putting -10 and 10 in braces. But we would have similar results for other absolute values. So if we were going to solve this equation, the absolute value of x equals 132, we could go right to the answer. We know the numbers that would have a distance from 0 of 132 would be -132 and +132. So those are the solutions. I'm not going to answer in braces each time, but you certainly could. For this next example, we'll add a little bit more to it. Suppose the equation were the absolute value of x plus 13 equals 45. Well, if we just subtract 13 from both sides, it will be an equation much like the ones we've just solved. So subtracting 13 from both sides gives us the absolute value of x equals 32. So we can see what our solutions are. They better be -32 or +32. And this one is complete. Notice how it would be different if we had the equation looking this way. The absolute value of x plus 13 equals 45. Now those absolute value symbols act like a barrier. I cannot subtract that 13 from both sides because it's inside that absolute value. But I can separate this equation into the two equations. But here's what we know. This quantity, x plus 13, better equal 45 or -45, or this equation wouldn't be true. So let's write those two equations. X plus 13 equals -45, or x plus 13 equals +45. And when we solve those two equations, we get x equals negative 58, and we get x equals 32. So we have the two solutions for this equation. Notice the results were different when the 13 was inside the absolute value or outside the absolute value. Let's solve this next one. It is the absolute value of 3x minus 10 plus 21 equals 50. There are actually a variety of ways to solve absolute value equations. I'm going to be consistent with what I did on the previous examples. I'm going to isolate the absolute value first and then separate it into two equations that combined are equivalent to the absolute value equation. So for this problem, let's subtract 21, and that will isolate the absolute value. So we have the absolute value of 3x minus 10 equals 29. Now we'll separate it into the two equations, and we'll have 3x minus 10 equals negative 29, and we'll have 3x minus 10 equals positive 29. And let's solve both of these equations. Adding 10 to both sides, I'll have 3x equals negative 19, or x equals negative 19 thirds. On the second equation, I'll have 3x equals 39. When we divide by 3, we get x equals 13. So there are two solutions to this equation. They are x equals negative 19 thirds or x equals 13. Here's our next example. The absolute value of x equals negative 50. Now it is tempting just to write x equals 50 or negative 50 because after practicing a few, people start to have an expectation that they'll have two solutions. But consider this. The absolute value of 50 is positive 50, and the absolute value of negative 50 is positive 50. So in fact, we don't have a number that we can take the absolute value of and get a negative 50 as a result. So there is no solution to this problem. So we would simply write, not this, no solution. Or we could use our empty set symbol this way. And it doesn't have to be a basic equation as the one is on the left. It could be a more complicated problem like the absolute value of x squared minus 42x plus 103 equals negative 600. And sometimes people jump in and start working away. But this is really a matter of observing that we're trying to take the absolute value of a quantity and getting a result that is negative. We know that can't happen. The results of it taking an absolute value are either positive or zero. So when we see an absolute value of a quantity equal a negative number, we can immediately say there is no solution and write the empty set symbol. Now take care that that is actually the scenario that you have happening. Let's look at this next example. It will be 50 minus the absolute value of 8 minus x equals negative 12. So sometimes if I put this on a test, I'll have students immediately say there's no solution. They're just happy they recognized that there's an absolute value equation, there's a negative number, and they jump to that conclusion. But let's look at it a little bit more by isolating the absolute value. So that means we're going to subtract 50 from both sides. And we have the opposite of the opposite of the absolute value of 8 minus x equals negative 62. to isolate the absolute value, we need to divide both sides by -1. So that the -1, that is the coefficient of the absolute value of 8 minus x, will cancel. So our equation becomes the absolute value of 8 minus x equals a positive 62. And we do have some numbers that will be solutions to this equation. So let's set up our two equations. They are 8 minus x equals negative 62, and 8 minus x equals positive 62. For the left equation, we'll subtract 8, and we'll have the opposite of x equals negative 70. Divide by -1, and we get positive 70. For the equation on the right, we have the opposite of x equals 54. Divide by -1, and we get x equals negative 54. So our solutions are negative 54 or 70. We'll solve one more equation. This one will be the absolute value of x squared plus 5x plus 2 equals 2. You'll notice that our absolute value is already isolated on one side. So I'm going to set it up into our two separate equations. So we'll have x squared plus 5x plus 2 equals negative 2. And we'll have x squared plus 5x plus 2 equals positive 2. So we have two quadratic equations to solve. Let's set each of them equal to 0. That means we're going to add 2 to both sides. So we'll have x squared plus 5x plus 4 equals 0. And we'll have x squared plus 5x equals 0. Both of these equations are factorable. The one on the left will factor into x plus 4 times x plus 1. And the one on the right will factor into x times x plus 5. So each of the two equations will have two solutions. So we'll find we have x equals negative 4, x equals negative 1, x equals 0, and x equals negative 5. And this absolute value equation has 4 solutions.